In today's lesson, we will cover inverse right triangle trig. This is going to be useful to help us find unknown angles in a right triangle. Now, we've used triangle sum theorem before to solve for missing angles in triangles. For example, if we knew two angles, we could find the third angle. On the other hand here, in this right triangle, I only know one angle, I don't know the other. So I can't use triangle sum theorem, but we can use trigonometry to do this. Now, inverse, that word should sound familiar. So here's an example from a previous chapter. So you have f of x equals 2x minus 5. And if you remember, we multiply by 2 and then subtract 5 in the order of operations. The inverse, on the other hand, the first step would be add 5 and then divide by 2. And to check my work, if I were to substitute 10 into the original function, the output would be 15. And so the inverse should undo that. I plug in the output of 15 and it gives me 10. So just keep that in mind about the inverse and that notation here and how that relates to trigonometry. Okay, so here are the journal notes. In a right triangle, to find the measure of an angle, we can use inverse trigonometric ratios. So we're going to solve for x. The steps. Set up the trig ratio based on what is known. Use the inverse trigonometric function of both sides of the equation to find the measure of the angle that will yield the ratio. Okay, so if you look here again, I want you to solve for an angle, but the issue is we only know the right angle. I don't know the other, so I cannot use triangle sum theorem. But I do know two sides of a triangle, of a right triangle. So that's a good sign to use trigonometry. Okay, so I'm going to draw my little person here at my reference angle. Okay, so x is our reference angle since that's the acute angle we want to solve for. If you look here from your point of view, the 3 is your opposite and the 10 is always the hypotenuse. Now, going back to SOHCAHTOA, we got an O and an H, so I'm going to use sine. So we're going to write sine of x equals 3 over 10. Now I'm going to write this notation here. It's going to look crazy, and I'll tell you what you really only have to write. Okay, I'm going to write this sine with a negative 1. In other words, this means inverse sine. Okay, of sine x equals the inverse sine of 3 over 10. Okay, that's a little weird, and I'm taking this to Math 3 level, but basically what happens is the inverse and sine cancel each other out. That's my point a little bit earlier. And what you're left over with is x. And then on the right side, I'm left over with this inverse sine of 3 over 10. Okay? You're going to take your calculator to compute the angle now. So, if you've wondered what this negative 1 thing was by sine, here's what you do. Now, for a lot of calculators, what you're going to usually have to do is hit second or something similar. So I'm going to hit second and sine. Okay, oops, I should probably make sure my calculator's on. Second and sine. And there's the inverse. I'm going to type in 3 divided by 10. Okay, and the angle is about 17.46 degrees. Okay, I want you to highlight our approximate answer, and this is what I call the exact answer. Okay, if I didn't have a calculator, that's as far as I can get. So we have our exact and approximate answer. Okay, so we set up the trig ratio. I took the inverse of both sides. I've got my exact answer, and that's where I'd stop if I had no calculator, and then approximate it because we're not that nerdy. We don't want to say the angle's that. We want to actually give a real number for that. Okay, that makes more sense. Okay, second example. So, the acute angle that's labeled is our reference angle. From your point of view, well, the 27 is still the hypotenuse no matter what. The 15 is the adjacent leg, so we'll put an A. So, looking at SOHCAHTOA, we're going to be using cosine. Okay, so cosine of the missing angle is equal to 15 over 27. Okay, we take the inverse of both sides. Okay? And once again, this is more Math 3 level-ish. The inverse cosine and cosine cancel each other out, quote unquote, and so therefore I'm left over with x. So x equals the inverse cosine of 15 over 27. Okay? That is technically your exact answer. That's all I can do if I didn't have a calculator to approximate. Okay, so there's my exact. Alright, now let's approximate. So x is about, okay, take our calculator, and I forgot to mention, always make sure you're in degree mode. Okay, so we've got second and then cosine. If you haven't noticed yet, these functions are paired up with their inverses. Okay, so inverse cosine of 15 divided by 27, and x is approximately 56.25 degrees. Okay, and there is the approximate answer. Okay, next one. Okay, we got a right triangle. I want to solve for an angle. I don't know the other one, so we're going to use trig. Okay, so the x is my reference angle. From this person's point of view, the 8 is the opposite leg, the 14 is the adjacent leg, so we're going to use tangent based on SOHCAHTOA. Okay, so tangent of the angle that I want to find is equal to the opposite, which is 8, divided by 14. Now, I told you guys a little bit earlier, you don't have to show all this work, and what I mean by that is we don't need to show this taking the inverse of both sides, okay? Like I said, that's more Math 3. I just want you to understand that cosine and the inverse cancel each other out. So, once you set up your ratio, you can jump straight to this. So, x equals inverse tangent of 8 over 14. By the way, some textbooks and some teachers might say arc tangent, arc cosine, arc sine. It's kind of an old school way of saying that. You'll hear me just say inverse tangent. Okay, so x is approximately, okay, so second inverse tangent, 8 divided by 14. And we have an answer of 29.74 degrees. Okay, so just a few, we're just looking for 3 steps, just a few steps here. Okay, you set it up, give us the exact answer, and then of course approximate your answer. Okay. Oops. Now I do want to show you guys common notation that students show that's incorrect. Okay, so I want you to compare both of these. So suppose the problem you had was sine x equals 10 over 17. The next step would be you take the inverse of both sides, but you could just jump from here to here. Okay, and that is correct. A lot of students will do this. Okay, it's as if the sine magically moves over here, but it moves onto this side. And this is incorrect notation that's going to cost you points. Let me show you why. On the calculator, if you were to type in 10 divided by 17 and then hit the inverse sign and hit enter, it's going to say an error. Okay, this always must be in front of the fraction. Okay, so we don't want to do that. So always make sure that your notation is correct. Set up the ratio, and then you have the inverse of that trig ratio.